Hello class! Today we're gonna learn about heat energy. So, let's start. So, what is heat? Heat is defined as the flow of thermal energy that transfer from a hot object to a colder object. For example, heat flows from the handle of a hot metal ladle to the cooler skin of your hand. Or similarly, if you leave a metal spoon in a glass of hot milk, the spoon will become too hot to hold. Or when you touch a cup of hot of coffee or a glass of cold orange juice, you will immediately sense how hot or cold the cup of glass is. To understand this concept, the heat and temperature will enable us to understand the physics concept behind this situation. Then, what is temperature? Temperature is the measure of the average kinetic energy of the particles of a body. Here is the picture showing the relationship of heat to the motion of particle. As you can see on the first glass, it shows that the faster the motion of the particle of the body, the higher the temperature of the body. Likewise, on the other glass, you can see that the lower the temperatures indicates that the particles are moving slower. This is an instrument for measuring temperature. This is called thermometers. Most thermometers consist of a thin tube filled with liquid. As the liquid in a thermometer gets warmer, it expands and rises in the tube. As the liquid gets cooler, the liquid contracts and drops in the tube. There are three scales of conversion dealing with temperature. First, we have the Kelvin. The Kelvin scale is the temperature scale often used by scientists. The 0 point in the Kelvin scale is called the absolute zero. We also have the Celsius. The Celsius scale is used to measure temperature in the metric system. The unit of temperature in the Celsius scale is the degrees Celsius. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And we also have another temperature scale used today is the Fahrenheit scale. The unit of temperature in the Fahrenheit scale is the degree Fahrenheit. In this scale, the freezing point of water is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit. This scale is commonly used in the United States. Now let's move on to heat and phase change. Phase change is the transition from one phase to another. And now, let's move on to heat and phase change. Phase change is the transition from one phase to another. The change of phase from solid to liquid is called fusion or melting. The temperature at which this change occurs is called the melting point. When a substance changes from liquid to solid, The change of phase is called solidification or freezing. The temperature at which solidification occurs is known as the freezing point. The change from liquid to gas is called evaporation. The change from gas to liquid is called condensation. The temperature at which a substance changes from liquid to gas or from gas to liquid is called the boiling point. During a phase change, energy is added to or removed from the substance in the form of heat. However, the added or removed heat does not cause a change in temperature. This is why temperature remains constant during a phase change. Here is the heat of fusion. When the amount of heat needed to change 1 kilogram of substance from the solid phase to the liquid phase without a change in temperature is called the heat fusion. Energy required to change a substance from a solid to liquid. In heat vaporization, this is the production of the vapor or gas from matter in another phase. When the vaporization process occurs in liquid, it is called evaporation. When it occurs in solid, it is called sublimation. Here is the thermal expansion of solid. Have you ever noticed the small gaps in railroad tracks and bridges? This gap provides an allowance for the tracks or bridge to expand during hot days. Similarly, inflated tires tend to get bulkier in warm weather than in cold weather because the air inside the tires expand as temperature rises. This example illustrates thermal expansion. The thermal expansion is the increase in size of a body because of heat. Generally, matter, like solid, liquid, and gases, expand when heated and contracts when cold. Here is the illustration of thermal expansion of liquid. When a liquid is heated, the kinetic energy of its particle may increase. As the particles move faster, they move farther away from one another, causing the liquid to expand. Here is the thermal expansion of gas. The expansion of gases when heated is due to the increases kinetic energy of the particles. In general, gases expand much more than solids or liquid do when heated. If the temperature of gas, a liquid, and a solid is raised by the same amount, the gas will expand the most, the liquid less, and the solid the least. A hot air balloon is one of the applications of the thermal expansion of gases. Heating the air inside the balloon makes the air less dense because the air particles move farther apart. Since the density of the air inside the balloon is lower than that of the cooler air outside, the balloon rises. Also, the thermal expansion of gases also affect weather and climate. The thermal expansion of air due to an increase in temperature in a particular region causes the air pressure in that region to drop. Thus, denser air with higher pressure move into the region, resulting in wind formation. By monitoring and analyzing this phenomenon, weather forecasters are able to predict weather. And class, remember this concept. Heat is a form of energy transferred from one body to another due to a temperature difference between them. Next, the temperature of a body is a measure of the average kinetic energy of the body's particle. Internal energy is the sum of potential and kinetic energies of the particles of a body. And adding heat or removing it from a body can cause changes in the body's size, temperature, and pace. Generally, matter expands when heated and contracts when cold. Water exhibits an anomalous expansion. And for your activity, kindly get your book and answer page 66. That's all.